In this problem, we are investigating the relationship between cyclic groups and their powers. So here we have A is a power of some B. A equals B to the K. We are asked to prove B is a power of A if and only if the cyclic subgroups generated by A and B are equal. And this is actually a lot easier than it sounds. It's basically just unraveling the definitions. So since A is a power of B, everything that you can get from A is already a power of B, right? Everything in here has to live in here because a power of anything here is then a power to a power which lives in here. So in other words, I have to prove the reverse direction is also true if and only if they're equal. But that's kind of obvious, right? Because, for example, if B is a power of A, then B equals A to the, I already used K. So how about J? And if that's the case, then the reverse inequality, the reverse containment is true. But now as sets, if I have A is contained in B and B is contained in A, then as sets, these two things together just imply that they're equal. Easy peasy. On the other hand, if they're equal, for the reverse implication, if I assume that they're equal, then what that means is everything in here can be written as a power in here and vice versa. So in particular, B must be in this group. That's the same thing as saying that B is equal to some power of A. So we're done. Much simpler than the previous problem.